Hello everyone. Today's topic is on when resistors are connected in series. So when you say that elements are connected in series, if they share one node common and or they're connected back to back, all the elements if they are carrying the same current, then we can say that elements are connected in series. So suppose consider this small circuit taking resistors R1, R2, C. Here the source and R1 is carried has one node in common here. Between R1 and R2 there is one node in common, and R2 and V there is one node in common. So and they are connected back to back also. One more, all these elements they will carry same current. Okay. Now let the voltage across R1 be V1 and let the voltage across R2 be V2. Okay. Now if you apply KVL, this branch current will be same as the loop current because all the elements are connected in series. So let us apply KVL. So KVL states that sum of the algebraic voltages around any loop is equal to 0. So we'll get minus V plus V1 plus V2 equals to 0. So V is equals to V1 plus V2. This is equation 1. Now from Ohm's law, what is the voltage across R1? V1 is nothing but product of current flowing through that resistor and its resistance. So it is I into R1 and V2 is I into R2. This is equation 2. Now substitute this 2 in 1. We get V is equal to I1 I into R1 plus I into R2 equals to, okay, so V is equal to, take I as common, so we're getting R1 into R2. So the sum of these resistances can I consider as R equivalent is equal to R1 plus R2. That means when resistors are connected in series, their equivalent resistance will get added. If n resistors are connected in series, if n resistors are connected in series, then R equivalent is equal to R1 plus R2 plus R3 up to plus Rn. Okay. Now, series circuit is also called as voltage divider. That means total supply voltage will get divided among resistors upon their which depends upon their resistance. Means if the resistor is having more, if if the resistor is having more value, then voltage drop will be more across that resistor when compared to the other resistor. Okay, so now here we can I write I is equal to E by divided by R1 plus R2. So let this be equation 3. Now I'll use this 3 to obtain the voltages across R1 and R2. Now from equation 3, I'll substitute equation 3 value in equation, substitute 3 in, we have V1 is equal to I into R1, but what is I? V divided by R1 plus R2 into R1. Okay, so I can write it as R1 divided by R1 plus R2 divided into V1, sorry, into total voltage. This is V1. That means if resistance is high, then more voltage will be dropped across that resistor. Similarly, V2 is equal to I into R2. That means V by R1 plus R2 into R2. So that means V2 can be written as R2 divided by R1 plus R2 into V. Thank you.